This is a short introduction to the OpenFluor database. OpenFluor is a searchable online library of fluorescence spectra. At present, it contains two types of data. The first are fluorescence measurements of some pure organic compounds dissolved in water. The second are paraffin decompositions or paraffin models of natural organic matter fluorescence measurements in environmental samples. You can reach the database at www.openfluor.org. At the welcome screen, you'll find links to further information. For example, the OpenFluor article here. This links to our ResearchGate page where we post updates about tools that are available, templates, and we answer questions. At the top here, you can register for a new account, or you can log in if you have an account already. I'll log in, and that takes us to the dashboard. At the dashboard, I have four options. First, I can browse the database and look at all the different datasets that were submitted. I can here access my account, and that includes datasets that I've uploaded to my account and then published into the searchable database, and also datasets that I've uploaded to my account and then kept for my own private use. I can perform a search on a text file of fluorescence spectra located on my hard drive, and that text file should be formatted in the same manner as you see in this example model. I'm going to browse the database. Here is a list of all the models that are in the database, or all the datasets. If I scroll down, I can see there are 73 different entries into the database. They all have a unique ID number, and that ID number doesn't change even if data in the database are updated. Search for my own datasets. Here I have the Dr. E model. As the owner of that model, I have permission to share that model with other people. I can also edit the metadata, so the data that appears on this page here, clicking on the Edit Model page, and I can export that data set into a text file by clicking here. You can see that the data are here. You can see the excitation and emission spectra. From the dashboard, I can access my account. Here I see the subset of data sets in the database that I am the owner of. As the owner of a data set, I have the ability to share that data set with other people according to their email address. In addition to datasets that I have published in OpenFluor so that they're searchable by other people, I also have a number of unpublished datasets that are only visible in my account. I can still share those datasets with other people if I wish, but they're not searchable by anybody else. From the dashboard, I can run a search pressing here. Can browse to a file on my computer which contains some fluorescence spectra that I would like to compare with the database. First thing that happens is that it gets uploaded into my account. So if I go now to my account, if I sort by the ID number, I will find that the dataset that I just uploaded here, I can edit that dataset and re-export it if I wish. From here I can run a compare or a search. Right now, while it's thinking, it's comparing the 7 spectra in my uploaded model with all of the spectra currently in the database. So that is going to take a while for a 7-component model. Although if I abort that process and come back to it, it will continue where it stopped. So it's going to take about 30 seconds for that. In the meantime, we can have a little look. The excitation spectra look like this. The emission spectra like that. If this were a published data set, which it's not, I would be able to submit it, publish it here, and that will move my model to the main database. Go back to the compare, and that process is finished, and this is the match models page. So this is the main results of the search. On this page you can see the settings that we used to perform the search. The default is that a minimum Tucker congruence of 0.95 is used for the excitation matching, and the same criterion is used for the emission match. When you multiply those two together, you get the TCC or Tucker congruence value overall. If that overall value exceeds 0.95, then the match is shown shaded here in green. If it's less than 0.95 and more than 0.9, then it's shown in yellow, and if it's less than that, it's shown in red. A graphical depiction of all of the matching spectra are found when you click on these buttons at the top of the page. You see the excitation spectra on the top and the emission spectra underneath. You can see from this that they're not particularly similar in some cases, and so we can make that criterion more stringent for matching, where we could take a 0.97 match on the excitation and let's go higher on the emission spectrum. We still have a large number of matches, particularly for this first component. Let's have a look at that. You can see now there are more similar appearing components. This is these graphs are interactive, so if I click on somewhere on the graph, for example here, it will rescale to the maximum value at that wavelength. Now that can be useful to emphasize changes in shape. You could do the same thing here, and it becomes a little bit more easy to see which particular data sets are a close match compared to others. Back to the match matrix page. We can export the data by clicking here, which will open it will save a file in CSV format, which can be opened easily, say in Microsoft Excel, and it will contain all of the matching data and the matching spectra.